Hello, let's take a look at an overview of section 4.4. In this section, we'll take a look at tangent planes and linear approximations. Much like tangent lines, tangent planes would be our linear approximation to a surface, just like tangent lines are linear approximations to the curve. So we'll define a tangent plane, and then we'll take a look at how to find a tangent plane. The derivation of this formula comes from the idea that we're going to take the partial derivative with respect to x and make a vector out of that that's tangent to the surface, and then the partial derivative with respect to y, make a vector of that that's tangent to the surface as well. And then by doing the cross product, we'll end up with a normal vector, and with a point in a normal we can find the equation of a plane. Next, we'll use this very same equation of the plane as a linear approximation. Just like in Calculus 1, it's going to turn out that our best linear approximation will be exactly that linear approximation, or tangent line, or tangent plane in this case. So, as long as we stay close to the actual point of tangency, our approximations are going to be good. And the farther out you go, the less reliable the approximation will be. Next, we'll define differentiability by looking at some errors. We'll not go too deep into this subject, but the idea is there. The idea of differentiability talks about our error from our tangent planes going down to zero as you get closer and closer to zero. And some important outcomes from that says that if you have something that's differentiable, then it's necessarily going to be continuous. And also, if you have continuous partial derivatives, that's going to imply differentiability, and that's also going to work towards our idea that our mixed order partials are equal. Next, we're going to take a look at differentials. So differentials are ways to express our differences, our small differences, using the tangent plane. Differentials, if you remember, take a look at small errors that are close to the point, and using the tangent line again, we're going to be able to derive the idea of differentials. And if we take a look at a visual of this, a differential now will just be taking a look at the difference between the tangent plane and what the surface is actually equal to. Finally, we're going to extend these ideas to functions of 3 or more variables. Again, the idea of a tangent plane now goes into a tangent space. It's more like instead of a 2-dimensional plane, it'll be a 3-dimensional idea of a plane. And again, there's going to be the idea of an error, and having that error approach 0 as you get closer and closer to your values. If that will actually approach 0, then you actually have something that's differentiable. All right, that is our overview of section 4.4. Good luck.